Question number 3. An arithmetic series has a first term of 3, a last term of 47, and the sum of all the terms is 300. First question, determine the number of terms in the series. So we are required to find what our value of n is. How many terms were added to get that sum of 300? First, writing down the given information. Our first term, which is the value 3, and then our last term indicated by L, we've got 47, and then our S of sub n, the sum, 300. And for arithmetic sequences, we've got two ways to find the sum. So the first formula, we have n divided by 2 into 2a plus n minus 1 times the common difference. And then the second one, n divided by 2, and then we sum our first and the last term. So in our case, we'll use the second formula because we know what our a is, and also we know what the last term is, and the only unknown is the number of terms. So we know the sum is a 300, then n divided by 2, and we have 3 plus 47. Okay, this is just let's say 300 times 2, we'll have a 600 there, and then a 50n, and then divide everything by 50. So the number of terms, 5 into 60, okay, 12. That means the number of terms that we need to add to get 300, that is 12 terms. And then now the second question, determine the common difference. So we'll use the first formula because now we know how many terms we need to add, and the only unknown is the common difference there. So we'll say 300 is equals to 12 divided by 2, then 2 into 3, plus our number of terms, which is 12 minus 1, then times our unknown. Now to simplify this, 12 divided by 2, we've got a 6. So I'll divide both sides by 6. I will therefore have 300 divided by 6. And what remains this side? I have a 6 plus, this will be 11. So 11d. Now 300 divided by 6, that is a 50. So I'll have a 50. Then I transpose my positive 6 to the left, which will be a minus 6. Then 11d. Now this will be 44. And then divide both sides by 11. Therefore, the common difference is 44 divided by 11, which is just 4. Now, find the sum of 4 into half raised to the power n plus 1, where n is from 2 to infinity. So before we find the sum of this nth term, let us first write down at least the first 3 terms of this general term. So our n starts at 2, right? That means I'll say 4 into a half raised to the power, we'll have 2 plus 2. So a half raised to the power 4. This will be a 1 divided by 16. So I'll have 1 into 1 divided by 16. And then the second term, we have 4 times. Okay, now we'll substitute n is equals to a 3. So we'll have 3 plus 2, which is a 5. So a half raised to the power 5. I'll have 1 divided by a 32. Okay, it doesn't matter the third term. So I think this is enough, because we'll use only these two terms to find what our r is if need be. Okay, we can further simplify this. This will have 1 divided by 4, and then this is a 1 divided by a 16 is 16. 4 ones, and then it goes how many times? 4. Okay, 8 times. This is 1 divided by 8. And now we can say our a is equals to a quarter, and then the ratio will just say the second term divided by the first term. So that means I have 1 divided by 8. I'll just multiply by 4. So this is 1 divided by 2. So this is our value of r. And by observation, you should notice that this is a geometric sequence, because only with geometric sequences where we can add terms to infinity. Unlike other, such as like your quadratic linear patterns, we always need to know what our terminal point is. However, the moment we're adding numbers to infinity, you should notice that this is a geometric sequence. So the formula that we'll use to find the sum, we'll have our sum to infinity, a divided by 1 minus r, where r is not equals to 1. So we know what our value of a is, we found that, and then we know what our r is, we have that. So now we can find the sum. 1 divided by 4 divided by the difference of 1 and a half. So in this case, we'll have a quarter divided by a half. So I'll just write this as divide by half, and then this is just the same as a quarter times 2, which gives our sum to infinity is equals to a half. And then the last question now. In a geometric sequence, the third term is 5p plus 1, the fifth term is 4, and the seventh term is 1. Determine the value of p. So we know that our nth term for a geometric sequence is defined by nth term is equals to a times r raised to the power n minus 1, right? And then for each of these given terms, we'll substitute them into our nth term, right? So we've got our t sub of 3, and then t sub of 5, and then our t sub 7, we've got the value 1. So I'll create 3 equations with the given information. The first one being t sub 3, we'll say 5p plus 1 is equals to, we don't know what a is, so we just write that as a, and then we say r raised to the power n minus 1. However, since we know what our n is, we'll say 3 minus 1, which means we'll have 2 then. And then for our t sub of 5, we have 4 is equals to a raised to the power, we know our n is 5, so 5 minus 1, we have 4 there. Similarly, with our seventh term, we'll have 1 is equals to ar to the power 6. And now, once I have my equations like that, let us first solve for r, right? And how we'll do for that, we'll find our ratio. We can use, in this case, let us use these 2 equations. Let us not use this first one, because we've got our p, which is our unknown, and we've got like 3 unknowns. We've got p, a, and r. So, but once we use equation number 3 and 2, equation number t sub of 5 and t sub of 7, and we use these two equations to find our ratio. We can easily cancel out our a's, and then we'll remain with only one unknown, which is our ratio, the first variable that we want to simplify for now. And once we have this variable of r, we can use either equation number, this equation and this one, or this equation and this one to solve for p. So let us find the ratio. Let us say t sub of 5 divided by t sub of 7. So we'll have 4 divided by 1 is equals to ar to the power 4 divided by ar to the power 6. Our a's cancel, we've got 4, and then we just find the difference of our exponents. We'll have r is, we'll have 4 minus 6, which is a negative 2. So I can rewrite this and say 1 divided by r squared. And then just to make r my subject, we can have r squared is equals to a quarter. I just inverted both sides, so hence I have r squared is equals to a quarter. And then let us find the square root of r. So r is equals to plus minus the square root of 1 divided by 4, which is equals to plus minus 1 divided by 2. So this is our value of r, plus or minus. So in my case, I will choose to use my r is equals to a minus, right? And it is advisable that you check for both the ratios. So in my case, I'm choosing to use r is equals to a minus half because I'm noticing that as my sequence progresses, my values, they decrease. Notice that for t sub of 5, we've got 4, and then progressing our sequence at t sub 7, we are getting the value 1. So I'm assuming that my r is a negative half. So now I will use that r is equals to a negative half. I will take the ratio of t sub 3, and the simplest one, let me take this one with the 1, t sub of 7. So we'll have 5p plus 1 divided by 1 is equals to ar squared divided by ar to the power 6. My a's will cancel, and then let me just say r squared minus 6. This side will have 5p plus 1, and then this will be r to the power minus 4. So I can rewrite that as 1 divided by r to the power 4. I know what my value of r is, so I've got only one unknown in this equation, which is the variable p. So I will substitute r as a negative half. I will have, let's say, 1 divided by negative half raised to the power 4. And that right hand side will give me, let's say, 1 divided by, I'll have a positive number, which is going to be 1 divided by 16, right? So this is just the same as the numerator times the denominator will have the value 16. So 5p plus 1. Now I can solve for my p. I'll have 5p is equals to 16 minus 1, which will be 15. So divide everything by 5. So I have p is equals to a positive 3. And I think if ever, let's see, we take our r as a positive, we are going to get the same value of p, right? Yeah. So that means our p is equals to a 3.